Okay, in this video we're going to talk about the problem and then we're going to talk about the solution. So stay tuned. Okay, let's start with the fact that when the internet superhighway was originally designed, it was designed as a 4-lane highway and the majority of the traffic was web pages, therefore the World Wide Web as it was known back then, and the other traffic was file downloading that became available also. But the internet was never designed to handle the level of traffic that the advent of streaming video has introduced. So the internet is overtaxed by this amount of data that the streaming video introduces. Okay, the internet superhighway. What we have is a 4-lane interstate highway. What we need is a 16-lane highway to handle all of the data that is currently trying to be pushed across the internet. So how do we solve this? Option 1 would be to upgrade the internet around the world by installing more fiber optic cables everywhere at a cost of billions if not trillions of dollars and a tremendous amount of time to accomplish this. By the time they got it done, it would probably be over capacity still, because the amount of traffic on the internet grows by the day, 75% of which is streaming video. Option number 2 would be to build new data centers in every major population center around the world to serve up the videos to the local population in surrounding areas, thereby offloading a lot of the data from the internet backbone to just the local area itself. Again, very time consuming and very expensive to do. Option number 3, find a way to use the existing infrastructure more efficiently. Introducing the THETA network. How does it work? Well, we place what's called an edge node, actually many edge nodes, in a major population center, and the server farm on the west coast or wherever it may be, when there are requests for a particular streaming video, they send one copy across the internet to one of those edge nodes, and the edge node will relay that to the other edge nodes in the area, who will relay it to the end consumer of the video. So essentially what you've got now is one copy of the video going from the server farm at, say, YouTube, and going to a edge node in, say, New York City, and then maybe there's 1,000 people in New York City that are all wanting to watch that particular video. So that one edge node that receives the copy from the server farm distributes it amongst other edge nodes, and eventually it ends up getting to the end consumer through the use of those edge nodes in the area. Who pays for these edge nodes? Well, YouTube pays by buying what's called T-Fuel, which is the currency of the THETA network, and it pays that out to the edge nodes based on the amount of data that they relay to other edge nodes or to the end consumer, and there's a certain amount of T-Fuel per megabyte of data that is transferred. So that is how the edge node system works. It's much cheaper for YouTube to purchase T-Fuel on the open market, which is the same market that the edge nodes will sell that T-Fuel into to convert it into dollars, and the whole system works. As a matter of fact, in many cases with the edge node caching system, the YouTube server farms don't even have to send that video, because the edge nodes keep the most commonly requested videos cached on their systems, and so when the request comes in, they've already got the video and they start sending it out to where it needs to be in the local area. So this whole edge node system works well because it's fast, it's cheap, and the YouTubes of the world are going to gravitate over to using it because it's going to save them a tremendous amount of money. Not to mention it's going to solve the buffering problem that drives this whole thing, because there's not going to be the need for the videos to travel across the internet backbone to get to where they need to be. They're going to already essentially be where they need to be in the population centers. So if you're running an edge node, then you're going to be incentivized to do that, because you're going to receive payment in the form of T-Fuel for relaying video, and your computer, your edge cacher, is going to already have one or two or maybe three of the most popular videos on the hard drive that it can serve up on demand as needed. And it divides each of those videos up into little tiny pieces, each being 2 to 3 seconds worth of the video, and it knows who needs what segment of that video, and it serves it out. When you consider that someplace like New York, for example, is probably going to have 1,000 or 2,000 edge nodes there, if each one of those edge nodes is caching 2 or 3 of the most popular videos, then essentially they've got a data center that has 2,000 to 3,000 videos already in the local area. So all they need to do is transmit the information to the edge node as to, say, the IP address of the person that wants the video, and let the edge node take over from there, serving up the video. The THETA network knows which edge nodes have which videos, and so it's able to instruct those edge nodes to do what they need to do. And by you participating, you're contributing and you're getting paid T-Fuel. And in the case where a consumer requests a particular video that isn't already cached in the local area, then YouTube will simply transmit that video to one of the edge nodes, and then it'll get handled from there. Because the THETA network essentially offloads 99% of the video streaming traffic from the internet backbone, because of the way it handles things, the rare occasion when YouTube actually has to send a video onto the edge node, say in New York City, it happens almost instantly because there's no traffic to slow it down. So it's a win-win. Essentially, those 500 or 1,000 edge nodes located in the population center, because of the way they work, they are in effect a virtual data center, but a lot cheaper virtual data center than what YouTube would have to build bricks and mortar and staff maintenance personnel and so forth, which is time consuming and expensive. So using the THETA network and its virtual data centers, is really beneficial for YouTube and anybody else like YouTube that switches over their content distribution to use the THETA network. They're going to save a tremendous amount of money by doing it. So just a matter of time before these people start partnering with the THETA network for their video distribution. And it's been asked, well, why wouldn't YouTube just go out and create their own system patterned after the THETA network? Well, they can't, because the THETA network is patented. Their method is patented. So YouTube would have to come up with something that would work similarly but not infringe on the THETA network patent, or they'll get sued. And it really makes no sense. They see it works, they should use it. It's the easiest thing they can do. Okay, this graphic here shows the T-Fuel open market and how the T-Fuel will flow to the content creators, YouTube, etc. Then from there it will flow over into the edge nodes, who will then sell their excess T-Fuel back into the market. And the price of T-Fuel will rise and fall based on the demand and the supply. So the edge nodes may decide to hold their T-Fuel until the price goes up, and then once the price reaches a point where they're willing to sell some of it into the market, they'll sell it into the market at whatever the prevailing price happens to be, and the content creators will buy it, and the cycle just continues. So seems like a good system to me. Well, that's it. Hopefully this presentation has helped you to better understand the THETA network and how it's going to change how things are done. And if you liked it, found it helpful, please give it a like and be sure to share it, and I'll see you in the next video. If you enjoyed this video, please like it, share it, and most importantly, hit that subscribe button. Thanks for watching.